everyone, welcome to the Titans series. Now if you are here in this video, you know that this series we are not just about foundation, we are moving a step forward. We are going to start a new chapter, units and measurements. Now you might think, ma'am, this was not in 9th, this was not in 10th. So beta, we are starting a Titan series. Now what is in this Titan series? So your goal of cracking JEE, of NEET, and if you just love science a little bit more than the rest of the world, then this series is for you. So we are starting a little bit we are going a little bit deeper into physics of the chapter units and measurements. We'll start with the very basic and you won't have to know anything. Do not worry at all that this is 11th level. No, I am starting this right from the basic, right from scratch. All the things we studied in class 9th, class 10th, we'll combine them and we'll study this chapter, units and measurements. This is a very important chapter in JEE as well as in NEET. A lot of questions come from this chapter, and this chapter is like the foundation of all other chapters in your class 11th and 12th, and it's very easy. So it's just a bonus point if you want to learn this chapter. Now beta, it can be a little bit boring. I agree to that. When I started with this chapter in the class, so in 11th sir started with deep into this chapter and I was like, I don't want to take science. But this is not where we are going. We are going to start this in a very fun manner. A little bit of maths will be here, but be with me as we progress. You will see. Now the results might not be visible in this span, but you will see after 2 years when you start your JEE preparation, NEET preparation, you will see how easy all these lectures, this Titan series made that hard syllabus for you. Okay, so without wasting any time, let's start our first chapter, units and measurements. Now this is a bridge course, so let's start from the first end of the bridge, that is your class 9th. Now beta, even in class 9th, when we started the chapter motion, or the new chapter named as describing motion around us, we studied one very important thing, that there are some quantities in physics, right? And those quantities are either scalar or vector. Now when we talk about physics, we basically study about physical quantities, the quantities we can see around us, like what, ma'am? Like mass, like length, like speed, like distance, and all that we studied in our class 9th. Correct? If you are in class 9th, that's good. You must be remembering this. If you are in class 9th and you forgot about it, this is the exact video for you. It will revise that chapter as well and will give you a little bit more for 11th as well. Okay, now beta, talking about those quantities, we said that, ma'am, scalar quantity is the quantity which only has magnitude. That means if I write 5 or if I write 10 meters, or let's say anything, right, 10 meters, or I write 5 meter per second, but this is a speed. So all these quantities which just have a magnitude, that means a number, that is a scalar quantity. Vector quantity on the other hand has magnitude plus direction. 5, or I can say 10 meters in south, 10 meters in south, 5 meter per second in north. So they have direction associated with them. They have direction associated with them, and that is why beta, this is called vector quantity. Now what are the scalar quantities? Those were, ma'am, speed, distance. So when I move, when I go from here and to here, I will count 2 steps there and 3 steps here, total 5 steps. But in vector, that is, what is the example of vector? Displacement. In displacement, we saw what? The initial position and the final position. So I was here, I went 2 steps there and 3 steps backward. So 5 steps. Distance. Initial and final position. 2 steps here, 3 steps here. So this is the initial position, this is the final position. This will be the displacement, shortest path covered, and this total will be the distance, right? So you understand the gist of it, you understand, you revise, you remember all of these things, right? We studied a lot about this in proper depth. Now beta, talking talking about a little bit more, going further in your JEE and NEET, you will see two kinds of more quantities. These are scalar and vector. Scalar which has only magnitude, vector which has magnitude plus direction. That's clear, right? Now in class 11th, you will see there are two more kinds of quantities. These are fundamental quantities and these are derived quantities. What are these? The fundamental quantities. Ma'am, what are fundamental quantities? See, where should I place it? Yes. So, fundamental quantities, beta, are the ones which already exist in the nature. That means we tell cell is the fundamental unit of life. Atom is the fundamental unit which makes up everything, right? So what do you mean by fundamental? That it can't be broken down. What does it mean? It means that it can't be broken down. Okay, that's what the basic meaning of fundamental is. So now beta, you tell me, what is the formula of distance? Ma'am, there is no formula for distance, right? Distance is simply how much paths we have covered. Exactly. So you cannot break down the distance. Now, tell me one more thing. What is the formula of velocity? Ma'am, that I can say. What is the formula of velocity? Distance upon time. Okay, so speed can be written as distance into time, but distance cannot be written as further. Why I am trying to tell you? You will say, ma'am, distance can also be written as speed into time. Yes. Now, listen to me very carefully. Move backwards a little. There is a confusion, right? That's the exact confusion we are here to clear. See, fundamental quantities, beta, these can't be broken down. Okay, so distance can't be broken down. Mass, kg, gram, can it be broken down? It can't be broken down into more smaller units. Time is also second or millisecond, hour, minute, but can it be broken down? Now these can't be. These are the fundamental quantities, and because of these fundamental quantities, all other quantities exist. Now we'll move to that quantities as well. First, let's study about fundamental quantities. Okay, now beta, length is a fundamental quantity. Okay, how much distance you covered, so you measure it. You don't derive it through a formula, right? You measure the distance and then you come back. Okay, I covered 5 meters of distance. 5 meters of distance. So that's a fundamental quantity, and with that we are studying their units. Okay, now beta, what are units? See, I tell you I covered 5 kg of distance. You will laugh on me, right? What is 5 kg? Kg is used for what? Kg is used for mass. Okay, no. I covered 5 seconds of distance. Array, second is covered for time, right? Is used for time. But we are measuring what? We are measuring distance. Now you understand? These units, when they combine with words, these units, beta, when they combine with a value, it gives a certain meaning on what we are measuring. Get 5 tomatoes. Now, what do you mean by 5 number of tomatoes, or 5 kg of tomatoes, 5 gram of tomatoes? So that kg gives the meaning to 5 as well as to the tomatoes. Understood? So that's exactly what we are looking at here, and you have studied about units as well, right? So what is the unit of length? Ma'am, it's meter. That's how we know. That's how much we know, at least. What's the unit of length? That is meter. SI units. SI units are meter. It can be kilometer, it can be millimeter, it can be centimeter, but SI unit is what? SI unit is meter. Then beta, mass. What is the SI unit of mass? It's kg, right? 5 kg of apples, 5 kg of onions, 10 kg of potatoes. So we measure mass with this kg, right? So kg, beta, is the SI unit of mass. Understood? Then we have time. Ma'am, what is the fundamental, how time is fundamental? Can you derive time? Is there any formula for time? No, ma'am. We just have a watch. We just have a digital watch. We just have an analog watch, right? So, beta, we measure the time, right? We measure the time. So, time is also a fundamental unit. So, in my language, okay, in my language, I call fundamental units as something that we measure, that can't be derived. That can't be derived. It does not have any formula. Mass does not have any formula. We get a weighing scale, we put the thing and we measure it. Length, we does not have a formula. We go, we measure the distance. Time does not have a formula. We see the time, tick, 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 and that's how we measure the time. Okay. Same beta electric current. Now you might not be up till that point, but in the second half of your 10th class you will study about time, electric current. So you'll see ampere is the SI unit of electric current. Then similarly all these things, temperature, we measure temperature with degrees Celsius, Fahrenheit, Kelvin. Now this Kelvin beta is so much used in class 11th and 12th. You will learn this and cram this, that whenever you hear Kelvin, it's temperature. So Kelvin is the SI unit of temperature. Degree Celsius, degree Fahrenheit are also the units, but Kelvin is the SI unit of temperature. Okay. Similarly, we have amount of substance, that is mole, luminous intensity, that is candela. Mole we again studied a little bit. We started in exploration, the new class 9th, right? But you will study this in 11th chemistry in depth. Now beta, in class 11th, possibly you will be studying these three and this temperature. So length for meter, mass is for kg, and time is for seconds, temperature is for Kelvin. That's how much you have to remember for now. Okay, ma'am, why are we studying this? I don't get it. Beta, you go to market, if your mother tells you to get 5 meter of tomatoes, so that will be a problem, right? So everything should have a specific unit with them. Now you go and you see, you sit with your friend and you say, how far is your home from school? And you say 200 steps. And he's like, what? 200 steps? How will I measure 200 steps? I won't walk. I'll come by bike now. Okay, then you're like, okay, 30 elbows. So you want me to stay there and put my elbows down there, right? Am I going to some yatra? So beta, why am I telling you all these? These are the ancient methods we used to find length, to distance, to temperature and all that stuff, right? So what happened? See, I don't want to tell you my height. I don't know, I'm very small, short, not that, but okay, whatever my height is, my brother's height is like 6 feet. So my one step is obviously does not match with his one step. So his one step is so much bigger, mine is so much small. So you tell me, if I tell him that cover 200 steps, but I told my steps, his steps will be larger. He will reach so far away with 200 steps, right? So that's the reason why we needed prominent units, standard international units, so that when I tell that the distance is 5 meters from this certain places, it will be the same distance, the same length in India, in Germany, in Spain, in UK, in USA, in anywhere in this world, in North Pole, in Antarctica, everywhere 5 meter is the same length. Everywhere. Now this can be different for different persons. Footsteps can be different, elbow lengths can be different, but 5 meter, it's the same for the person here, it's the same for the person in Alaska or Antarctica. That's true, right? So that is why we got the concept of units, so that we understand what it is meant for, and it is same everywhere in the world. Okay, now beta, after fundamental, what we are talking about, these are not derived. So what are derived? Now all your confusion will be cleared. So derived units beta, velocity. Ma'am, how is velocity? We also measure velocity. My bike gives the velocity, right? See, your bike gives you a value of velocity, but that's not because it's a fundamental quality or quantity. It gives you your value of velocity, the speed it shows on the odometer. Why beta? Because it calculates the distance the bike is going for. It calculates that it is traveling for 5 kilometers and it did it in 10 seconds. So then we find out the velocity, the speed. Right? That's when we find out the velocity. But ma'am, every second bike is giving, it's not waiting for 10 seconds. Yes, because the formula, the machine inside the bike is calculating the speed every millisecond, every second. So we are traveling 10 meters in 0.1 seconds. So it is using that formula to calculate the velocity. So beta, what exactly is happening? Distance we covered, distance we measured, we went there physically, we saw that it's 100-meter distance. And time also we will measure with the help of watch, right? With the help of watch, I said that time is 2 seconds. In 2 seconds I covered 100 meter. Now what is the speed? What is the speed? So speed, you will say that ma'am, speed will be distance upon time. Distance upon time. How much distance is covered in how much time, right? That's it. That's it. So your speed will be what? 100 meters, and time is what? 10 seconds. So this cancels out. Your speed is 10 meter per second. We will talk about this in just a second. Now remember, see, I told you that this is derived from two fundamental quantities. One of them is distance, one of them is time. Done. Speed is a derived quantity. Speed, beta, it is a derived quantity, and it is derived from what? It is derived from these two fundamental quantities. Understood? So whenever you see someone is telling you that we are going with 10 meter per second speed, then you know that speed is not a fundamental quantity. You derived it by dividing the distance with time. Understood? And that's why hence the term, you understand, right? Fundamental is basic, that can't be broken, but velocity, it can be broken into distance and time. So it is derived from distance and time, and it can be broken into distance and time. Understood? So speed is derived, but distance and time are not. They are fundamental. They can't be derived, they can't be broken down, but speed can be broken down into distance and time. Understood? Now beta, similarly then we have velocity. We studied about velocity in class 9th, right? We studied about speed, we studied about velocity. What's the difference? Speed is a scalar quantity, velocity is a vector quantity. Speed does not have direction, vector. This velocity has direction along with the magnitude. Understood? Now beta, SI units are meter per second. We just wrote, right? Now the formula is distance divided by time. So distance is meter, time is second. So I can write meter per second as the SI unit of speed. SI unit of speed. Understood? So we have other units as well, other derived units as well. What are those? Acceleration. What's the formula of acceleration? Tell me fast. Tell me fast. Yes, it is what? Velocity upon time. It is velocity upon time. Velocity formula was what? Displacement. We studied speed in the previous slide. Now we are talking about velocity. So velocity is not distance upon time. It is displacement upon time. Very good. Then beta, what is the next one? Momentum. We studied about momentum as well, right? So momentum is what? Mass into velocity. Mass into velocity. What is force? Ma'am, force is mass into acceleration. Mass into acceleration. What is work done? Ma'am, force into displacement. Force into displacement. And energy is what? Energy is just work done. So can I write force into displacement? Now beta, all these things, power is what? Work done upon time. Power is work done upon time. Okay, now beta, can you see every single of this quantity can be written as two or more quantities. It is written as displacement upon time. Acceleration is made up of velocity and time. Momentum is made up of mass and velocity. Force is made up of mass and acceleration. Work done is made up of force and displacement. Power is made up of work done and time. So all these can be broken down or reverse. All these are derived from these fundamental quantities. See, displacement is fundamental, time is fundamental, but in here velocity and time, velocity is not fundamental. Yes, but can I can I write velocity as fundamental as well? So acceleration is velocity upon time. But ma'am, velocity is not fundamental. So let's write it in the form of fundamental. So velocity is also now what? Displacement upon time. Displacement upon time, but this time was also there, so this time is already here, right? So displacement, unit of displacement is what? It is meter. Unit of time is what? Second into one more second, so this can be meter by second square. S into S square. So acceleration has meter per second square units. See, this can be written as fundamental quantities, as a mixture of fundamental quantities, or it can be derived from fundamental quantities. But these, can displacement be broken down further? No, it can't be. Can time be broken down? No, it can't be. And it has fundamental quantities, and it has SI units, meter per second square, and hence we have acceleration unit as meter per second square. So all the fundamental quantities have specific units, but derived quantities also have units, but those units are also derived from the units of fundamental quantities. Understand? It can be a little bit hard if you say, but it's very beautiful. You'll understand slowly. I'm going very slow. We don't have to fast track through it. We don't have to run through it. We are just understand, take a chill pill, sit down and try to grasp all these things in your brain, so that your brain will also think, something new is here. Let's study. Let's try to understand. Okay. And all these things are from 9th class. We are not even started the class 11th yet, you know. Okay. Similarly, beta, we have momentum. Now momentum, what is the formula of momentum? Momentum, ma'am, it is mass into velocity. It is mass into velocity. Again, velocity is not a fundamental quantity, so let's write it in the terms of fundamental quantity. Mass into, what is the formula for velocity? Ma'am, displacement. It is displacement upon time. Right? So what is the unit of mass now? It was kg, right? Displacement is length, distance, displacement, length. Everything has a unit m, and that is meter, right? What is the unit of time? Ma'am, second. So what are the units of momentum now? Kg meter per second. Is that the unit? Kg meter per second. That's the unit. Force we have studied. Now this is very good. Force, beta, we have studied. Where is force? Okay. Force, we have studied M into A. Okay. Force, we have studied M into A. Now, beta, what is the unit of M? Ma'am, that is simply mass, kg. What is the unit of acceleration? Let me write it down in the form of fundamental quantities. Acceleration is what? Velocity. It is velocity per unit time. Okay, but velocity is still not fundamental. Okay, so let me write it down in the form of fundamental. Velocity is displacement, just like we did it before. Displacement upon time, and this time is already here. This time is already here. So now, can displacement be broken down? No. Can time be broken down? No. So this is our final phase. So kg, displacement is what? Meter per second square. S into S. So SI unit of force is Newton, but that Newton is the name we gave it. Dimensionally, according to this formula, what is the unit of force? Ma'am, kg meter per second square. This will be the final formula of the units of force. Then, and we call this big thing as Newton. We call this as Newton. So Newton is the SI unit, which is equal to kg meter per second square. Understood? Done? Understood? You can understand a little bit how we are reaching this point from this particular point. Okay? Now beta, since we have talked a lot about units, right? We are talking about units this, units dash. In ancient time we were using steps, and then we using elbow, distance, then meter. But there is one thing that is very weird and different. What is that? Beta, sometimes you say my house is 100 meters away, sometimes you say my house is 100 kilometers away, sometimes you say my house is mega kilometers away. And what is this mega now? You'll understand. So you understand this, and you say how long is this stylus? Well, this is 10 centimeter long. So all of these are units of length: meter, centimeter, milliliter, millimeter, kilometer. All these are units of length. But why do they have different units? That's where we come across a thing called system of units. So beta, in Europe, you might heard of it as that we measure our weight in kgs. I am 50 kgs, I am 55 kgs. Okay, but in Europe, how will you say I am 100 pounds, I am 150 pounds, and some other place you will say I am 10,000 grams, I am 50,000 grams, although nobody says that. But all these are the units of kg, unit of mass, right? Kg, gram, tons, quintals, pounds, all these are what? Units of mass. So somewhere they're using kg, somewhere they're using pounds, somewhere they're using something else. So, but everything they mean by one, that is system of, that is mass, right? So that is where the system of units come into play, and we have to study that also a little bit. Now beta, basically there are three kinds of system of units, that is FPS. That means your distance in foot, we know, right, how much height we have. I'll say 5'2", 5'3", I have 5'5" height. Okay, that's how we say 5 foot 5 inches. That's how I say. Okay, so feet or foot is the unit of distance, again length, right? Then CGS, centimeter, gram, second. Now in here the unit of length is what? Centimeter. MKS, the distance of the unit of distance is what? Meter. So you understand, all these are the units of length, all these are the units of distance. Understood? Then beta, we have FPS. So P is what? P is what? Pound. That is your weight. So for weight in FPS system, for weight we use pound. In CGS system, for weight we use gram. In MKS system, for weight we use kgs. All these are weights, but they are depicted in different units, right? Then beta, in our FPS system, the time is measured in seconds, but in CGS and MKS, time is always measured as seconds. So that's one thing you have to take out of your brain. Done. Now beta, this MKS, that is what? Meter, kilogram, second. Meter, kilogram, second. That means when you go somewhere, you will say 100 meters. When you weigh someone, you will say 100 kgs. When you tell the time, you will say 100 seconds. Understood? That is regarded as the SI units. SI units, standard international unit. So whenever something major is being happening, that means sorry, some scientist is doing some research, okay, or he is writing some paper on his research, so he will use standard international units, that this is the amount of substance I used, 0.1 kg, 0.001 kg, or they'll have to convert into kgs to do the experiment. So everywhere in the world, all the machines, all the workers, they are operating on one single unit, standard international unit, that is MKS system, distance for meter, mass for kg, and time for seconds. Understood? That's the one thing. Okay, now you will see lots of calculations written here, but don't worry, that's one part of it. Now beta, now let's say I measured distance, I measured my weight in gram. So I'll say 2000 grams. Okay, now someone in Europe has their machine programmed in kgs. Let's say, okay, they have their machine programmed in kgs, but I say I took 2000 grams. So they have to convert this gram into kgs. They have to convert this gram into kgs to put that value into their machine and do the operations, right? So how will they do that? What is this whole thing? This thing is called beta conversion of units. This is called conversion of units. So after system of units, we will study about conversion of units. That means how one unit can be converted into another, how kg can be converted into gram, how meter can be converted into kilometer, how hours can be converted into seconds. Can seconds be converted into meters? No. Can kg be converted into milliseconds? No. Millimeters? No. So that's why we specified that these are the units of length: meter, centimeter, kilometer. These are the units of mass: gram, kilogram, milligram. These are the units of time: seconds, hour, minutes. So these can be converted with each other, not with each another. Okay, so that's the one thing you have to remember while converting units, although it's very common sense, but anyway. Now beta, when we talk about, I hope everybody knows, I'm assuming that 1 kg is equals to 1000 grams. We all know that. Sometimes we go and ask, Anna, get me 500 gram of this. Okay, or sometimes you go and, bro, get me 1 kg of this. Bhaiya, get me 2 kgs of this, 2 quintals of this. Depends on the amount and thing we are trying to do with that particular thing, right? Now beta, see one thing in this very clearly. When we have kg, now kg is a higher unit. Obviously, why? Because 1 kg is 1000 grams. That means gram is a smaller unit. Gram is a smaller unit. Why I'm saying? Because beta, you have this one beaker. Okay, you will say you have 1000 grams of grains in it. So gram, if you want grains in gram, you have to take more grains, you have to depict them as more grains. That is 1000 grams. 1000 grams is a big number, but gram is a small unit. Gram is a small unit because 1 gram is definitely not equal to 1 kg. So 1 gram is very small. So you have to get 1000 of grams to make it equal to 1 kg. That means kg is a bigger unit, gram is a smaller unit. Kg is a big unit, gram is a smaller unit, right? If you want some heavy stuff, you will get 2 kgs of it because kg is a bigger unit in itself. But you'll get 2000 grams of it because gram is smaller, so you need more number. Understand what I'm trying to say? So why I'm telling you all this? Because beta, on this, that means that, wait, see, so you have 1000 grams and only 1 kg. Now, of course, the weight of these things are equal. I know that. It's not a trick question. Weight of these two things are equal. But I'm talking about units and the magnitude, the value of it. See, this value is small. This value is small, but this thing is big. So can I write it as 1 as number and this is unit? So number is small, unit is big. This is equal to 1000 grams. This 1 kg is equal to 1000 grams. Now here unit is smaller, but number is big. So can you see the difference? Number is smaller, unit is big. Number is big, unit is smaller. That means we get a formula from here that these are inversely proportional, right? Number smaller, unit big. So number is inversely proportional to the unit beta, and on this you will get N1 U1. If I multiply this, I will get NU proportional to constant or proportional to constant, and here this constant is 1. Constant means that value is not changing. So you will get a very important formula, N1 U1 equals to N2 U2. And here you will see the questions on conversion. Questions on conversion. Now still we are not doing that because it's a higher topic, but you just get the gist of it. You get the idea of it, what we are trying to do, right? Now beta, talking about that, now we are moving on to, okay, let's go back and understand this. Now, this is what I mean by conversion. That means 1 Newton has 10 raised to power 5 dyne. Okay, what do I mean by that? Ma'am, see, F equals to M into A. Okay, F equals to M into A. Now, this is 1 Newton. right? And this mass is what? 1 kg. Acceleration we just saw before. We did this before, right? Acceleration was what? Meter per second square. So write it down. 1 meter by 1 second square. This makes sense. This whole thing makes sense. Now beta, if I want to convert it into CGS. CGS means kg. See, MKS, that means kg, meter and second. I'll convert this kg into gram, this meter into centimeter, and this second into second. So this will be CGS unit. Now they will ask you to convert this 1 Newton into CGS. Now 1 Newton is what? It's an SI unit, right? And you want to give this number. You want to convert MKS into CGS. Now this is MKS. Let's convert it into CGS. In 1 kg, how many grams we have? 1000 grams, right? In 1 meter, how many centimeters we have? 100 centimeters. In 1 second, how many second we have? 1 second square. So that remains same. So just multiply this 1000 into 100, 5 zeros, and this will be gram centimeter per second square. CGS. And here it was what? Kg meter second. So I converted kg meter second MKS unit into gram centimeter second CGS units. So I converted the units, right? The system of unit is changed. So that means beta, this 1 Newton is equal to 10 raised to power 5 gram centimeter per second square. And we write this. See, just like we write kg meter per second square as Newton, we write gram centimeter per second square as dyne. So this 1 Newton will be equal to how many dynes? 10 raised to power 5 dynes. So 10 raised to power 5 dynes. So now tell me which one is the stronger unit or bigger unit, and which one is the smaller unit or the weaker unit. Let's say, not weaker but smaller unit. So Newton is the smaller unit or dyne is the smaller unit? Ma'am, we need more number of dynes. That means dyne is smaller. And we need only 1 of Newton. So Newton is a bigger unit, dyne is a smaller unit. So we need more numbers of dynes so that it becomes equal to 1 Newton. Okay, that's the whole thing this is about. Now beta, moving on, we have just one small topic in this whole particular lecture, and that is your dimensions. What are those dimensions? Remember, square of dimensions, 2D, 3D, 1D, photos we are clicking and all that thing. 2D, the photos we click is 2D. The one you are seeing me, watching me on a screen, so that screen is a 2D screen, but I am 3D. Is that dimension we are talking about? No, that's not the dimension we are talking about as of now. As of now, we are talking about something entirely different. That means beta, we studied length, mass, time, ampere, electric current, luminous intensity, mole concept and moles, all of this, right? Now all those are what? These are fundamental units. Units is the keyword, remember this. So these are units. Now beta, after we are done with units, unit is meter, second and kilogram and ampere. But there is something, when I say that length can be meter, centimeter, millimeter, kilometers, but all of these, we combine all of this and say that okay, their units are different, but all of these are lengths. So let me give it a different dimension and call them just length. And so whenever I have meter, centimeter, kilometer, millimeter, all these have one dimension because they represent length. All these have one dimension, length. And when you write dimension, how will you say that this is not length or something other than length? This is L, just random L written anywhere. So to make it clear that it's a dimension, we write it in a square bracket. So length, any length in this whole world, any length, number of steps, number of elbows, meter, kilometer, millimeter, micrometer, everything has a dimension of length, that is L. So length is for L, so we give it a dimension L. Similarly, mass can be what? It can be kg, it can be gram, it can be milligrams. So all these have a single dimension, that is m, written with square brackets. Same, time can be what? Second, it can be hours, it can be minutes, it can be milliseconds, but anywhere time is mentioned, it has the unit t. It has the unit t. You'll understand later. Right now we are not going to do the questions because those are a really little bit hard. You'll need some chemistry concepts with that, but we'll do some questions. I'll tell you how this is important. So ampere is what, beta? Electric current. So A is your electric current, right? So beta, all these things are the dimensions. Whenever any kind of length is mentioned, you will say L. Dimension is L, mass is m, and temperature is time is T. Temperature is written as the unit Kelvin, K. Okay, so all these are very important. Now let's try and see some questions. Let's see some dimensions. Now we derived the units of these quantities. These are derived quantities, right? So we derived their units. Let's derive their dimensions now. Ma'am, how will we do that? See, what's the formula of velocity? Ma'am, it is displacement. It is displacement upon time. It is displacement upon time. Now, ma'am, displacement is what? Displacement is distance. Distance is length. Length has a dimension and written as L, right? So it is L, and for dimension we'll write it in square brackets. Time is written as, the dimension of time can be written as T. So simply T. Now one more thing you have to include in this is this, that length and 1, you write it as 1. The power is 1, the power is 1. But if this time goes up, so anything that is in the denominator, it goes up, its power gets a negative sign. That means T was in the denominator, has a power 1. It goes up, it has a power now minus 1. So this is the final answer, and if you write it, you can write it LT minus 1. So this is the dimension of what? Dimension of velocity. Understood? Derived from the dimensions of displacement and time. Similarly, let's do for acceleration. This is what? Velocity upon time. Now dimensions of velocity we just found out. This is what? LT minus 1. What are the dimensions of time? T. Now if this T goes in the numerator, what will be its power become? Minus 1. LT minus 1 and another T with the power minus 1. Now, do you know beta, if the bases are same, that is T and T, bases are same, so the power will get add up. Minus 1, minus 2, right? If you add these two, you will get LT minus 2. LT minus 2. Understand? Now again, it can be a little boring, but it is interesting. Mathematics is a little interesting. Okay. Then beta, you have force. Force is what? Ma'am, which is the formula of force? Mass into acceleration. Mass into acceleration. Now, mass, what was the dimension of mass? Ma'am, it was simply m. What was the dimension of acceleration? We just found out, LT minus 2. LT minus 2. So how will you write this? You will write this combining m1 L1 T minus 2, or you can write it as m L T minus 2. Understood? These are will be known as the dimensions of force. Understood now? Understood completely? Any doubt? Now let's do two questions, very simple, and we'll end this lecture. And take a chill pill, do not worry about it. Go through the lecture again if you want to understand anything. And in the next chapter we will be studying about graphs of motion and some other topics. So what it will do for 9th class, it will refresh your memory and give you a little extra to understand the graphs better. And for 10th class, it's a refreshment. You have to refresh your concepts, recall your concepts after some time. So both of you have to join that lecture. Okay. Now, which of the following physical quantities has same unit in all three system of units? What were the three system of units? Ma'am, FPS, CGS, MKS, Very important, very easy. Ma'am, second. So which quantity has the unit as second? Meter. Mass. Time has the unit. So answer will be time. Done. This will be your answer. Next question and the last question, that is your, which of the following beta, which of the following is units of quantity? Which of the following is the units of quantity? Pressure gradient, displacement gradient, force gradient, velocity gradient. Ma'am, what is this? What is this? Now, let's understand this clearly. Beta, gradient is what? So, whenever we talk about rate, right, we studied about rate change of velocity. Rate change of velocity. Rate change of velocity, right? Or we studied about rate change of displacement. That means what? That all these quantities are getting divided by time. They are getting divided by time. That means this is velocity. This is velocity per unit time, right? This is what? This is displacement per unit time. These things are clear, right? Now similarly beta, we have one new word, that is your gradient. Gradient means per unit length. It means per unit length. Understand what I'm trying to say? See, they have mentioned pressure gradient, displacement gradient, force gradient, velocity gradient. So, see, when I talk about pressure gradient, what does that mean? Pressure gradient beta will mean that pressure per unit length, pressure per unit divided by length. Per unit length means divide by length. Similarly for what? Similarly for displacement gradient, it will mean displacement divided by length. Then same for force, it will mean force divided by length, right? Then it will mean velocity divided by length. Done. Velocity divided by length. Now beta, look at this carefully. They are asking that which one of the following is a unitless quantity. Again, understand one more thing in here. See, unitless and dimensionless, there will be two words. So every unitless quantity is a dimensionless quantity. That's one statement. Dimensionless quantity, and every dimensionless quantity is unitless. Now here you will study about one more thing beta. You have studied about angles. We studied in the previous classes 40 degree, 30 degree, 20 degree. So beta, in here we are not going to study the angle in degrees, but we are going to study our angle in radians. This is a supplementary quantity. We gave two quantities, fundamental and derived, but we forgot the third one. Supplementary quantity is angle. There are two angles. You have studied, you have read this in class 10th as well, or you read it, that now the unit of angle is radian. Okay, so this is what beta, theta is the angle equals to length of arc by radius of the circle, right? We studied this. Similarly, we have cone. You have that birthday caps, right? Those birthday caps are round like this. So that angle, the 3D angle on the top of the cone is called solid angle. That solid angle is area divided by r square. That solid angle is area divided by r square, right? So that's the whole concept of angles. Now beta, talking about angles, these have unit but they don't have dimension. See, why am I saying this? Now L is what? Length. So the dimension is L. Radius, R is also length, right? R is also length. So its dimension is also L. This cancels out and this comes out to be 1. So dimension is 0. Dimension is not 0. Dimension is not there, right? So it is dimensionless, but it has some unit. That means beta, a quantity can have unit but not dimension. That means there can be dimensionless quantities, but that does not mean that they are unitless. Your angle does not have a dimension, but it has a unit, that is radian, that is degree. Okay, but all the unitless quantities, that means the quantities that don't even have a unit, they are always dimensionless. Okay, so let's see. Ma'am, pressure has some units. Divided by length. It is not unitless. Why am I saying this? Look at this. Pressure beta is force upon area. Pressure per unit length is force per unit area into length. Does this cancels out? See, what are the units of force? Remember, it was Newton, but it was also kg meter per second square. Let me write it. Now you should remember this. What is this? Kg meter per second square. Here we have meter square into meter. So 1 meter cancels, but rest of the thing remains. So it has units. So pressure gradient is not the answer. Displacement gradient. Displacement per unit length. Displacement is per unit length. What is that? Displacement is meter. Length will also be meter, centimeter, something like that. So meter, this will cancel and this will be beta unit less. This will be unit less. So this can be the answer. Force gradient, force per unit length. So we have force per unit length. That means kg meter per second square. No, we have kg meter per second square, and in the denominator we have meter. This cancels out, but the units are still there, kg per second square. So this is also not unitless. And similarly, velocity gradient, velocity per unit length, meter per second by meter. This cancels out, but this second is there, 1 by second. So again, velocity gradient also has some units. So this can't be the answer also. So beta, this also. So your answer will be displacement gradient is unitless. Done. Displacement gradient is unitless. And that is where we end this lecture. You might find it a little bit boring. I can understand that. But this is the thing you have to go through so that you can see some very interesting chapters, which will be the next one. The goal is not very shiny. The goal actually is shiny. The path to that goal is not shiny. You have 4 years, you have 3 years. Make sure to use these 3 years and make it as boring as possible, so that after these 3 years, after your 12th class, you enter into an IIT and it can be as glamorous as you want. Okay, and that is why we started this batch Titans. And that is it for this video beta. I'll see you in the next one. Tata, bye bye.